Yeah, so I think I learned a lot from that talk by Sridhar. I think it was pretty eye-opening to kind of learn how machine learning is being adopted in a more traditional enterprise, like industrial. And just kind of recap, like I think we talk about use cases, platform, technology, and people, right? And one of the point that he didn't mention much about is sort of the challenges with data, right? Which is like how they always need high quality data in order to build, develop this model, and bring them into production. And timely enough, our next panel is a fireside chat. That we talk about the value of quality data. And then our two panelists on stage, Mo Saleh and Timothy Shokhe. So Mo is the chief engineer and the lead the data team at a company called Oshkosh Corporation, and they focus on IoT telematics analytics for connecting the vehicles and drawing insights from the data. I believe you also have a PhD in experimental particle physics, right? From Wayne State University in collaboration with CERN in Switzerland, and you have worked at CERN as a research scientist in particle and nuclear physics. And Timothy is the director of data science at Condé Nast, and coincidentally enough, he is also an experimental particle physicist turned data scientist with a decade of quantitative data analysis and simulation experience. He focused on extracting business value from many forms of structured and unstructured data. Prior to his current role at Condé Nast, he enjoyed roles at CCC Intelligent Solution, NBC, Universal Media, Discount, and iView. So with that introduction, welcome the panelists on stage. Yep. The theme of our panel, today is on the value of high quality data, right? And I guess why data is the building block for successful AI project and system. So maybe sort of the first question is you can talk about kind of a bit about kind of your role at your respective organization, and at what aspect that you work with data, more specifically in terms of data collection and data acquisition. Yep. So maybe Mo, you can start.
Yeah, sure. Thanks for having me here. Pleasure. Looking forward. So in terms of the data collection, I can start probably general here and go into more of our journey of data collection. I think the lesson learned is the sooner the better, right? The sooner you start with that data collection, the better you get to where you're trying to achieve with your data journey. I think it's a journey. It takes a lot of time, money, and efforts to get to where you're looking for. There's a lot of challenges. You start with people, technology, business expectation, and Schneider. We touch about these challenges, and starting more into each of these, you can talk about one of them is very important is the business expectation. I want to highlight and then get to a more of a example how we do it. Data collection is the first piece in your data journey, and a lot of time I see it, the business expectation set you to failure because they expecting a revenue out of that data collection where you currently is sitting just the infrastructure. So you have to make sure this is in mind first. We have to start. I'm not going to touch about people and technology. We all know that technology these days it's a lot of uh, companies, a lot of emerging technologies, every day changing. We see in the first talk a lot of these ecosystems and new systems. But in terms of our data collection journey, it's more of we deal with connected vehicles, telematics part of these vehicles. So we have a fleet of these vehicles. We collect all of these sensor, and we can talk probably about more of what quality data. And so that data collection, I think the lesson again learned start first, and agile is a key thing because you have to fail fast in your data collection. I'll talk more into later what this idea, business ideas, business expectation for that, but I'll give it to Tim at this point.
Thanks. Yeah, so I'm at Condé Nast, to which, if those of you are not familiar with Condé Nast, you probably are familiar with some of our brands. We're a magazine publisher, essentially. A lot of publications. You probably know New Yorker, GQ, Wired, Vanity Fair, Vogue, a number of others. So we really are a very old company, more than 100 years old, really focused in print publication. And as most print media companies really tried to evolve in the last couple of decades, there has been this transformation towards digital. And the idea is that there's a lot of data that could potentially have been captured in that print world, not so much on interaction or on use cases, but low level data that you can get. As you moved into this new world where digital data is available, you suddenly have lots more data points, a lot more things that you can utilize when you start to try to understand your users at the individual level. And so we really have kind of in the last 10 years as a data science team got organized, started with the use case, right? Started to try to say, like, what can we do? Can we focus on advertising? Can we collect data that's going to be relevant to what we need, to be able to say, let's target people with advertising, knowing about what they consume. And so we really did make this concerted effort to digitize and start collecting in a deliberate fashion how the data that we would like to have. So capturing events on people's consumption, but then also being able to understand the content that they're consuming, so to be able to represent that mathematically, to be able to use in data science models.
Yeah, absolutely. Thanks for kind of giving that high level overview about what does data collection and acquisition look like in your respective organization. Two very different use cases, right? One on vehicle data, telemetry vehicle data, and the other one more on sort of digital publication. And but I think the common theme here is that it's important to only collect the valuable data points, because there's a lot of data, but like you need to be able to collect the one that high quality and impactful for the business ROI, right? So maybe we can zoom in into that point. Like, I think you talk about like, we're already collecting data, but not all the data is valuable, right? So it's important to be very deliberate about choosing what stream of data to tap into, or what more specifically what data sample to collect, right? So maybe can each of you talk more about sort of the data collection strategy, and like how do you curate, right, the most relevant data points or data sources, so that you know that when the data come in, data already of high quality. Yeah, maybe Mo can start with it.
Sure. We all know garbage in, garbage out. I don't think anybody didn't hear that term, right? So you don't want to collect that garbage in to get that garbage out. I think whenever it gets to business, it's very important to see what we looking at the data. So we all heard about data is the oil, right? And I'm pretty sure nobody in this room didn't hear that term. But if we all know, if you don't do any refinement for that oil, it's just worth nothing. So that's where that refinement use will come into place. And if you want to put it into more of a business business use of that data, I always like to put it into three categories. One of them will start with what happened. You want to answer that question: what's happening and what will happen. And if you come from a data AI background, these are three levels: more technical, descriptive, predictive, and prescriptive. And that's now to take it into more of our journey. We started with collecting these data. It took quite a lot time to do all these data collection and know what you need to collect. And then you start to realize that in terms of the data collection, the first step is to start with dashboarding. You want to, in our case, is to have a fleet management, understand what your fleet is doing, how utilizing these vehicles. Whenever you give it to the business, we gave them that fleet management. It took them a year to take it, grasp it, and then they ask the next question is what we can do next, right? They were impressed by that dashboard, but a year after, they're gonna start asking what we want to do next. That's where we started more onto the predictive, what's happening. Use case, one of these could be we done and deploy it in production, is doing a truck statusing. You want to know what this truck is doing in near real time. Some example we have is cement mixer trucks. We're not talking about if he's driving or not. Is he at the job site? Is he doing what need to be done there? And that's the second level. Another example would be what we work on is a driver behavior. You want to know how your driver is doing on the road. You want to give it a score. And this is one of these levels. Then the third level, that's more of a kind of more advanced into analytic and being able to use it. That's where we started to look into predictive maintenance. Many of us, it's a buzzword, predictive maintenance, but to put it into place and have a production model, that's very important. We had a lot of models deployed in terms of predicting in terms of oil, right? You want to know how much oil left on this truck. You want to know in terms of your battery management system, is there any alternator battery failure? So this is can cover of high level and 3 level of these use cases.
Okay, thanks. So, yeah, I think in our case, when we think about quality data, it means a lot of different things, but maybe 2 examples I can think of where we've had to make deliberate changes into how data is to be able to obtain quality data. So one example is, on a lot of our publications, there's what we call affiliate commerce. So this is like if you're on Wired and you're reading a review and there's a link to purchase something, that data is captured, collected. We were kind of making as we're thinking more about transitioning out of the third-party cookie world, how can we utilize our first-party data? How can we be able to build segments based on first-party data, knowing what somebody purchased? As we kind of started to dig into this data, it became really clear that there was no taxonomy, there was no labeling, there was no way to infer what kind of product somebody actually purchased, other than here's a link, here's a purchase behavior. So really, like that kind of became this intentional thing that we had to re-strategize. You have to build this taxonomy that says these are the kinds of products that exist. 2, you have to be able to say now this link is tied to this taxonomy, even though this individual product may not fall specifically, it may not be mapped 1-to-1. Maybe you need to have some higher arching taxonomy that's a little more comprehensive. And in that way, we've been able to kind of like start that transformation on the data side and then be able to collect that valuable data. The other example that we can think of is that we publish a lot of articles. Labels on articles, you can imagine, are really useful for a lot of NLP models. If you want to think about fine-tuning a transformer-based NLP model, being able to say, this article had this label, that's a useful piece of information that you could use. These labels, when we kind of started digging into them, once again, found they're all over the place. Like editors have a lot of freedom to choose, what they put, and some people may put one word and another word that may be different. Again, you can use NLP to kind of like solidify those things, but I think being able to start from a deliberate taxonomy and being able to say these are the kinds of things that we care about, these are the kinds of tags and labels that matter to our business and the things that we would eventually like to be able to predict, because it might help with recommendations, because it might help with organization, because it might help with advertising. Starting that transformation, I think it's a long journey to be able to get to the place where you have that quality data.
Yeah, absolutely. Thanks for highlighting both of those. So just quick recap, you talk about the 3 level of descriptive, predictive, and prescriptive, right? And how that apply into context of Oscar, and team talk about the 2 specific use cases of identifying taxonomy, and as well as the second one is on ensuring label quality when this article come in. So thanks for sharing both of those examples. Now, I want to talk a bit about, maybe we can discuss a bit more about the technology and the people side of making sure that, this whole process of data management, data operations is streamlined and systematized across, your context. So maybe we can talk about the people aspect first. So I guess like who are the people or department in your organization are responsible for ensuring high quality data?
Sure. So whenever, again, you started your data collection, we all had that mindset. You want to collect everything, and soon you realize you overwhelming your solutions, you exponentially going with the cost, and then you sit back and then look into what need to be collected. And then whenever you look at who is be responsible, I would like to bring up one concept we're seeing it lately in terms of a methodology about the data. We're seeing something called data mesh is presenting these days. The idea of that data mesh is to push back data collection, data lakes into more to the departments, the segment, instead of a centralized data collection. And there's a key idea, very important idea, like that methodology is now you're involving more of the domain people to be involved in that data quality. So to answer your question, I think one of these key importance is to have the domain knowledge involved in terms of these testing, experimentation, making sure you're collecting the right data. Because the data team will not realize about the quality of these data until it's too late, because you start that data collection, you thought what you thought, and then it's too late. Where the domain knowledge, you know these data from the first place. And then this is more of a on the experimentation in the first level. The second level, which we learned in the hard way, is data governance. All sort of, regardless of technology. Here we talk about people. Then you start to forming the team. I think also not only agile in terms of the use case. There's an agile methodology. You have to take it into the team talent and having the right people on the group. So you start. Many organizations make the mistake by starting with data scientists at the first hire, where you have to have at least a first data engineer, data architect. I think having the right structure of the team is a very key important here, and everybody learned it the hard way. I think at this stage we should start it right in the first place.
Sure.
Yeah, I think for us, we probably started like a lot of data organizations, a couple of full stack data scientists doing the data engineering, doing the machine learning engineering, building the models, trying to get them deployed. But we actually benefited, I think, a lot. You build these initial products, you show some success, and then you start to really build this specialization. And we've actually seen quite a bit of success with that. So we have a data engineering team that's not just there in support of ML products, they're in support of other places in the business. So when we think about like BI or different teams that want to be able to like understand reporting, the data engineering team is kind of like solidifying how that data is being collected and making it available. In addition to kind of creating pipelines for data scientists to be able to build their models, to build exploration. I think one of the things that I've seen success with as I've been in a number of places and seen a number of different models is this deliberate split between data scientists and machine learning engineers, and that may mean a lot of different things. But the way we think about it at Condé Nast is that we have data scientists that are building, exploring POCs. They're working really closely with machine learning engineers. In this case, are software engineers that understand how to deploy machine learning models and how to scale them. And one of the things that has been really beneficial of this structure is that we're pretty self-contained in everything that we do. We're not reliant on outside engineering teams to deliver products, and that has gotten us up to a level where a lot of the things that we build out of POC, they get deployed. If it gets built in POC, we have the resources within our own team to make it available. And being really deliberate about the hiring to say, don't hire too many data scientists unless you have enough machine learning engineers to support that is really important.
Yeah, absolutely. Thanks for sharing those insights. Just to kind of recap, we talk about like the importance of domain knowledge, right? That you need people with domain knowledge to understand the respective context of your organization to be able to run with data. So talk about sort of the importance of the right team structure. We'll talk about hiring data engineer first before making any other hiring for people with ML domain, and then team talk about making that clean separation between data scientists and ML engineers. One is focused more on the experimental phase of things, and the other focused more on the production level side of bringing those notebooks into production essentially. And as we transition more on that sort of context between going from experiment into production, right? I think it's very important to perform like experimentation and testing, maybe A/B testing and analysis of your data and your model in-house first before being able to actually maybe in your case ship it into the ML engineers to bring them into production. Can you talk about sort of the importance of testing experimentation when being data driven? Like how do you like either via a certain methodology or certain tools to ensure that sort of rigorous experimental approach? Yeah.
Yeah. Oh, sure. Yeah. So I think there's a lot of this idea of the enterprise embracing experimentation. It's like a nice buzzword that people use, but a lot of times it's hard to get people to put their money where their mouth is. So I can think of a couple of examples. In the publication world, there's this move towards dynamic paywalling and dynamic pricing, and a lot of these media companies are saying we should do that. And so as you dig into the data, you realize no, everybody's always gotten the same paywall, everybody's always gotten the same renewal price, and you explain to people that in order to build this model, you need randomized data to be able to understand somebody's preference. And so you say, okay, we'll kick off an experiment. And as you go to kick off this experiment, you explain to people there's a risk. This, when you change the gating, you may lose readers, you may lose page views, you may lose subscribers in the end if you raise the price. And I think there is this kind of culture shift that has to happen at the really executive level to be able to understand data is not free. You want to have these products that are going to have long-term benefit. You really need to be able to experiment with them, and sometimes those experiments may be costly. The data that you get out of them is valuable, and you need to have a plan for how do you utilize that data. And I think we as data scientists need to do our diligence in terms of saying, here's what the opportunity is, here's how this would work in an ideal world, here's what the risk is, and here's why we should make these trade-offs.
Awesome. Yeah, I think whenever you talk about data integrations, many of us follow some of these industry standard methodology like GRISP-DM, where you start with business understanding, data engineering, data science, machine learning, and then deployment. I think in our case, we extended that experimentation or this methodology. I'll give an example here. Whenever we collect data, we do all the data engineering, get to that model, and we want to deploy it. So the idea is to stop at that deployment. I think because we sit more into a product-focused engineering department, we extended it to more into another step. So a lot of these models, we take it and deploy it on the truck. But our extra step will be to also do a testing on that truck. So it's not going to end at that deployment. It's going to be deployed in the truck. So what we talk about always the lab and take it to a truck. So after you test it on the truck, you go back and another time you repeat that cycle of that GRISP-DM. That's very important because diverse data, a lot of things can come into play that affect that model piece and get that deployment to be effective as you see in the lab, to be in the real world and in the truck case.
Yeah, thanks for kind of, I think you both talk about sort of the importance of the data scientists taking ownership of making sure that we talk about the pros and cons trade-offs before executing this different experimentation. And I guess like specific to the context of Oxshot in your case, because you're working with IoT data on fleet vehicles, right? So there's a new challenges here of working with data on the edge device, right? Versus like maybe in the Condé Nast case more on a web native browser, can use cloud service for that. Maybe can you can you both talk more about sort of maybe we can talk first about the difference, unique challenges of doing data management on edge device, and how does that different from like traditional on-prem or cloud services? Yeah.
Sure. I think that's very applicable to our case. We always do development and then the deployment, most of the case, not every case, for us is on the vehicle. There's a lot of challenge. Edge computing technology, we all know a couple years ago, it's reached to the height. And now we start to see how it's going to be applicable into our industry. I'll give an example of these challenges we face. Part of that deployment sometimes it's our embedded software team. It's not somebody in the data team or have dealt with that data. And many of the time we have limited to what the deployment will look like. We all know decision trees or random forests will be much easier to deploy. So many of the time we get kind of overhead by what we can deliver as a machine learning model. That's one of these limitations. Another limitation I see on the edge deployment is how you can take your model to the edge. There is currently a lot of companies investing on how you do that seamless integration between that model. We all know most of probably 90% of the people work in the data science or machine learning use Python, and definitely it's not the way you have to take that model to the edge. So that get a lot of challenge in the integration part. There's a lot of the second thing, it's on the hardware computing part. Many of these models, if you start talking about deep learning, you're going to be giving overheaded by the computing power. So also you have to keep in mind, and that's very important, that's to keep in mind what you're looking to do at the end, so you cannot fail in the second part. You invest a lot of time in that modeling phase, and then at the end, you're not going to be able to deploy that model. So two things I from my own experience is the integration part and the computing part have to be taken care, explored before working on this use case.
Yeah, and in our case, we've really kind of started from going back to the use case and what's the value of computing something on edge, right? On the edge. In a lot of our initial products, really to show value, they didn't necessarily need that kind of rapid computing. There was not that much that you were going to gain from an individual session at that time to be able to say, okay, this person's likely to subscribe, or because their history is rich enough, like one new article may not push them over the edge to being someone who's going to book a luxury hotel or something like that. But I think as the industry is shifting a lot more towards, we need more personalization. One, we should ask why, but two, as you think about okay, here are the real places where personalization can give value. When we think about recommender systems, and we think okay, you are reading this article. The article that you're going to read next is highly dependent on what you read before. And this is kind of work that we're starting to explore now. How can we kind of take those, do as much as we can in batch, offline, and do only the necessary pieces on the edge to be able to solve those specific business problems.
Absolutely, yeah. I think those are very valuable insights, and kind of highlighting, realize your point about focus on the use cases when you do batch versus when you do streaming, right? I guess the last question for this fireside chat before moving on to the sort of the QA from the audience is that you both manager, right, or director of data teams at your respective organization, and I suppose one of the responsibility that you might have is to evaluate tooling, or vendors, or when to adopt them into your workflow, right? And I guess there's a couple of ways to do this, from building tools in-house to use open source solution to try out enterprise solution in the market. Maybe can you talk about sort of the mental models for or how to choose the right tools for the jobs that can enable your teams to be productive? Yeah.
Yeah, so I think we think about it in a way of we want to have our company data kind of in a unified format. So there's a lot of like collaboration with our data engineering and data warehousing teams to be able to say like these are the pieces these are the toolings that we can use to manage our data. We as data scientists, I think are often kind of one going back to like what is the business problem that we're trying to solve and how can a vendor potentially help us. So when we start to think like okay, here is a hole in where our technology is like not capable or where we're lacking, maybe falling behind something that we need to have, it then becomes what are the vendors that are out there, what can that vendor solve what we need to solve without giving us too much extra, and then thinking about like the long-term cost. I think for me, I try to think about how much effort is it going to take for my team to build a solution that would be customized to our use case, compared to how much it's going to cost to buy something in the long term. In some cases, you'll find something, and you know it's not a full solution, but it's a temporary solution while you can build your own. In other cases, it may be suiting your needs, and you'll never need to build that solution.
Yeah, I think I don't think anybody have a right answer for this. There's no silver bullet for all these technologies. The lesson I learned: if something works, just stick with it, because every day, every new use case could ask you to go and bring another vendor. Uh, Nonetheless, there's a lot of tools that make it easier for our team to work with. Some kind of more automated, um, just give them more into less time in terms of, let's say, data management, ML ops or so. And I see the problem currently in the industry. Some of these tools are dominated by big companies. So if you talk about, I don't want to mention names, but there's a lot of these big companies that advertise and have the power to have that technology pushed, which could be not the ideal, and people get kind of shifted to that technology because it's coming from a big vendor. I see a lot of opportunities, seeing a lot of companies dealing with a lot of vendors. There's always each company has a different aspect, and they maybe add value to your organization. So my advice: there is no if something working, just stick with it. You don't have to go to another if that working to your team, and if there is a specific use case that's out of the box, I think that's where you can try to look over for a specific solution.
So yeah, very, I like the simplicity of your answer. So we have about probably 3.5 minutes left for Q&A if anyone want to ask the question. Yeah, go ahead.
So, quick question for you guys. Can you share with the audience how you're dealing with unstructured data and how you're turning unstructured data into business value specifically?
Sure, I can start here. I think that's an everyday challenge. Unstructured data, I think the first thing we usually always address is, again, to my point, go back to the domain knowledge. If you're not able to push it back to the domain knowledge and get that emphasis, instruction on how to use these data, that's a big challenge. In terms of a technology, there's a lot of uh, technology that's in place to make that life cycle easier, and then to take it to the next level and to the value. That's where a lot of intense and work into the place where data engineering people will have to put a lot of time to turn these into more of a valuable. And these days, the data lake, why it's presented, it's mainly for that unstructured value. And we saw a challenge. It's not always resolving the problem. And now you can see there's a lot of talk about a lake house. That's where another methodology. So at this point, also there's a lot of paths, and we're seeing a lot of improvement and look for what could be done in the future.
So I think on our end, we think a lot. We have actually a really simplified use case. Like there's data about users, there's data about content, in a lot of our cases, things are fairly well structured. In some cases, they're not. And in those cases, I think we try to sometimes go down the POC route of how can we do unsupervised learning on some of these things? How can we be able to try to like extract some value? If there's anything there, that may be an effort going forward to like change and apply structure to some of that unstructured data. But I think it really is on like an individual use case. An individual use case.
Yeah, awesome. Maybe one last question from the back.
Yep. Knowing your data lake experience and data small, you guys say talk about that quite a bit, don't you? Internally. What about data labeling for those domain experts? Have you gone into that at all in terms of automating pipelines, trying to understand what's coming in, labeling it appropriately to ensure quality and obviously to ensure these data types are flowing like water with accurate data.
Yeah, I'll start here briefly for the sake of time. I think, again, that's a lesson learned. I think that goes under the data governance. We lately kind of tried to standardize a couple of these tools. Just one of these example, if you create a table, nobody will know who created it. Then you have to have it added as a attribute into your governance. Who the owner of that table? And in terms of more of the overall governance, that's still a challenge. I think a lot of that goes still in terms there is no a standard methodology how you want to do that labeling.
And I know we're out of time, but I think my philosophy on this really is, can you create tooling that allows those data experts to quickly and easily label the data as part of their process? So some of the cases you may want to automatically label it on your own if you need that expert opinion until your models kind of get up to speed. Really giving them tools to make it easy to label data. That's where you get value. It depends on if you need that data to solve a specific business problem.
Yeah, for this question, I think when you started your data journey, I don't think it's worth it. But whenever you're well known and know your data very well, that's where a lot of value comes in.
Perfect. Yeah, I think that's a great way to conclude our first session. I think to that point, labeling that whole sector has been evolved a lot, and there's a lot of tools, solutions that can make that process more efficient, get graduating from manual labeling to automatic that process. So I'm very excited to see how that process can be streamlined and become more efficient in the future. Thanks Mo and Tim for offering your insights in this first session.
Thank you.
Thank you.